to just begin by saying congratulations on behalf of Reliance for your recent award. I think echo what Ian said, really. And thank you so much for giving up your time to answer a few questions this afternoon. I thought we'd begin by talking around sort of AI and your experiences, and then move on to some applications in cyber, some of the problems to be overcome, and then finish off by sort of looking towards the future. I hope that sounds like a good plan.
That sounds like a good plan.
Perfect, perfect. So I wonder, when you first entered the field of multi-agent systems, it must have been a small research community. How did you become involved in AI and specifically multi-agent systems?
So you're right, it was a very small community. So I went to do a PhD at Queen Mary College on a EU-funded project, so one of the early Horizon programs. And the project was about distributed artificial intelligence, so about AI systems that would cooperate with one another to solve particular problems. And at the time, it was sort of, the AI systems were called expert systems, so, and that these would then work together to help cooperatively solve a problem. So in some sense, that was given by the project. I became interested in AI as an undergraduate. So I did computer science as an undergraduate, and got really interested in AI just from the thoughts and possibilities of trying to build and design a machine, an algorithm that would behave in a smart way. So I found that intrinsically interesting. Absolutely. And so I went to do a PhD that was sort of shaped around distributed AI, which later became multi-agent systems. So sort of distributed AI was the sort of in vogue word when I started, and that sort of morphed into multi-agent systems. And sort of I was interested in it because I thought, okay, if you can build one AI system, that would be great. But if you could build one, you wouldn't stop there. You would want to build more than one, and you would want to connect them together and have them interact in some way. So for me, sort of distributed AI multi-agent systems have always been a much more natural state of affairs than just an AI system in isolation on its own.
Yeah, I absolutely agree that it has an intrinsic interest. I'm from a maths background, and you know, I when I first got into maths, I had an enormous fascination with Enigma and what was going on there, which was sort of absolutely the foundations for this sort of thinking. And when I first came across these ideas, I completely agree. But I wonder, AI is quite a commonly known term, but when we think of AI sort of more in the public domain, multi-agent systems isn't something that springs to mind. I wonder if you could just give a brief description of what they are and why they're an important feature of AI.
Yeah, so your observation is right. I think people are concerned with sort of building an intelligent machine, and in fact or a robot, and that's what people think of when they think about AI. Mm-hmm. And in some sense, you need to have some AI together before you can build a multi-agent system. So an agent for me is just an alternative word for an AI system that can act with a degree of autonomy, that's connected to its environment and can take decisions upon it. The multi-agent bit of that is where you have a collection of these, and that collection might be from small numbers, 2 to 10, sort of through medium numbers, hundreds, to really big numbers, and it sort of encompasses all of those things. And so they will need to interact with one another, either because they need to work together to achieve something, or because they're in an environment where there will be resource contention. And so the interaction might be some form of cooperation, so working together. It might be some form of coordination, so sort of some might do this thing and some might do that thing, or it might be a competition, in which case they will negotiate with one another. And multi-agent systems is primarily focused on those interactions. So the work that I've done is I've developed algorithms that will let agents cooperate with one another, that will coordinate with one another, and that will compete with one another. And sort of, as I said, multi-agent systems are, I think, the next evolution of AI, because systems are all networked these days. Network connectivity and sort of is just the norm, and people will want to connect AI systems together. And sort of something that I've been working on maybe for the last 10 years is that some of those nodes in that network of things that are cooperating, coordinating and negotiating will be humans. So in the early part of my career, I was only concerned with computer programs interacting with one another. Mm-hmm. And sort of that only takes you so far is what I learned from doing that. And actually what you want is people alongside your AI working together. And so a multi-agent system might well be a mixture of people as well as AI systems.
I think that's really interesting, because we inherently think that computers are more predictable than people, but I'm not really sure with AI if that's the case.
I think they're genuinely sort of complementary in terms of what they can do. I mean, computers are fantastic at some things, going through lots of information, amalgamating data together in a way that is beyond human capacity, particularly if you want to do it fast and at scale. But humans do have something that computers don't, which is that sort of broader context and innate understanding of what kind of looks and feels right, and computers don't have that. And so I think many tasks you want elements of both of those things, which where I think the sort of the human AI partnership is really important.
Yeah, particularly I think the use case of driverless cars is always an interesting one, with the, as you say, the mass knowledge that the computer can have of experience, but actually the attention span of a person is not that great, but the collaboration there is really useful.
Yeah, and when the autonomous vehicles will interact with one another, so sort of crossing a junction, sort of avoiding rerouting in order to avoid traffic jams and the like. Driving a car is a close interaction between a person and a machine, but sort of in that broader system, road system, transport system, actually you want the cars to be interacting with one another.
Absolutely. I wonder if we maybe turn to a cyber example. I saw in one of your recent publications it outlined methods for the detection of dictionary domain generated algorithms in network traffic using deep learning. Mm-hmm. These improvements to the detection of malicious and C2 traffic is a really welcome achievement in cybersecurity, particularly for blue teams. I wonder how you see this research being integrated into existing infrastructure.
So I very much sort of think that cyber is a really important domain for AI systems. So, one of the joys of working on AI is, in fact, you can apply AI to almost any domain that you see fit. So, that's fantastic. And one of the things I've really enjoyed in my career is taking a tool that I have and know and sort of applying it in lots of varied domains. And so that I've really enjoyed. And cyber is an important one of those domains. And I kind of got into cyber during my time in government when I was the chief scientist for national security, where obviously cyber was an important part of my role, and sort of that really brought it to the fore, and I've sort of kept going with it since that time. Yep. And again, for me, it's a point where a modern computer system or network that an organization had is so complex and sort of so interconnected that just having people alone, or just having low-level tools that indicate quite low-level concerns just doesn't scale. It's not enough. There's not enough cybersecurity experts in the world to manage all of those systems out there. And so humans need more support from the machinery that they're using to help predict and protect those systems. And so the computer systems and the AI need to help them figure out sort of what's normal, what's abnormal, what to worry about, what not to worry about. And again, sort of it's sort of combining that sort of nous and understanding of an experienced cyber professional with the abilities of what a machine can do, which is that large scale, fast pattern analysis. And so it is a real power tool. And together, I think that has to be the central bit of the next generation of cybersecurity.
Absolutely. So we're really looking at sort of the next generation of aid for the cybersecurity analyst.
Yeah. So, you know, it's increasing the degree of automation, increasing the support that is being provided, because as the networks get bigger, more complex and interconnected, it's a harder job for a human to do in isolation. And so either you scale up the number of people you have doing it, in which case you have everyone on the planet in the end doing cybersecurity, or you get the machines to step up to the plate a bit more and be very much more active participant. And that sort of active participant, helpful colleague, which is what the AI can be in these contexts, is really where I see that bit of that partnership working.
Yeah, absolutely. And I think, like, going back to the car analogy as well, this is where the machines actually tend to perform better than people. We think about things with like alarm fatigue, and also the sort of global threat that these threats are 24 hours, that the computer doesn't need the sleep.
That we all do, thankfully.
Yes. I wonder if there's any sort of other applications to cybersecurity that are in the pipeline for integration with AI technology. Is there any prime candidates that come to mind straight away? So
I think it's interesting where we'll see sort of AI in the cyber domain. So I think sort of one is obviously around network defense. I think so, sort of monitoring what's going on your network, figuring out what's normal, what's abnormal, and flagging up. So I think that's there. I think around the testing of networks, so that networks have the ability to be probed continuously. So almost like well, not almost, that kind of automated continuous pen testing of a smart adversary, really trying to sort of probe and seeing where you can get weaknesses in the system. So sort of having the AI sort of fight a separate AI, trying to fight the AI that's already there, and that sort of gives you that sort of arms race. So I think you can do these things on a continuous basis. So sort of making them more secure, looking out for looking out for detections on the network, and then sort of I think in terms of being able to use the system and sort of verify users of a system. You know, we're gradually moving on from passwords to things like other biometrics like fingerprints and face recognition, and I'm sure AI will have and let us use other forms of authentication as well. So I think we'll see elements of that.
That's really interesting. My day job is a penetration tester, so currently, so that's your insights into that. I wonder, I have a couple of questions now on some of the issues thought to affect our AI systems and how we can sort of combat those. So I wonder, what do you feel are the greatest obstacles still to overcome in the development of AI?
So for me, there's a few of those. So, and one sort of, well, and I'll list them to you. So I think one is around the AI's ability to understand sort of when it knows what it knows and when it doesn't know what it knows. So in general, people know when they're at the boundaries of their expertise, and they know that actually I'm not really qualified to give an answer to this, or, you know, I'm going to give you an answer, but it's quite a weak answer and I wouldn't attach too much certainty to it. So that sort of ability to know your boundaries and know your limitations, AI systems are not very good at. The second thing is around sort of AI systems being able to explain and understand why they have made particular choices. So if you're looking at in medical diagnosis, or you're looking for to make a particular decision, then it's important, I think, that you understand and the computer can give a rationale for why it has come to a particular decision. And I think that's important, that you, as a human working perhaps alongside it, or being the recipient of a judgment from a computer, that you can probe and understand that. And a lot of the machine learning algorithms which have driven a lot of the current wave of interest in AI are quite opaque in that regard, and sort of are a black box and flipping difficult to get an explanation out of it. And then the third bit is sort of how AI can work with us as humans and fulfill its bit of a partnership side. So, at the moment when we interact with computers in general, it's we who have to be adaptive. We have to figure out how the computer wants to operate, and sort of we're kind of stuck with that interface. Yeah. Actually, machines are very poor at being good teammates or good collaborators. It's not something that they're renowned for, and I think sort of in the partnership model they have to get better at that.
Yeah, it's really interesting. Your first comment in particular was a surprise to me. I've never really thought of machines not being risk averse and being able to teach machines to be risk averse. That's certainly something I'd never considered before. But I certainly had more questions around the accountability. I think that is one of the more sort of well-known and documented issues. I mean, particularly if we're considering multi-agent systems interacting, does this further increase the complexity of systems and narrow the chance of making these algorithms accountable and understandable? Would you say this is a valid claim?
So I think if you have a system, a multiple agent system, particularly where you have agents representing different organizations or different individuals, is inherently more unpredictable than an AI system that's designed for one particular task by one particular organization. Having said that, sort of, even one AI system for one organization and one task has huge difficulties around sort of what you can know about its performance, particularly if it's adapting over time. So, even what you knew the system would do yesterday, if it's changed and adapted itself, you don't necessarily know the same today. And so multi-agent systems do make this harder. But for me, the upside of that is just its nature and and a natural way to model these sorts of problems. So you just have to accept it. And I think we will continue to try and develop better tools that will work on a software engineering side of things to be able to give guarantees about what the system will do and what it won't do. And I think the forms of guarantees that we'll give will be less hard and fast, black and white, than they are now. I mean, sort of, if you look at formal methods in computer science and software engineering, it's come on massively in the last sort of 5 or 10 years. The size of system where you can mathematically prove that it will achieve particular things or avoid particular other things, so your safety and liveness properties, has really expanded significantly. But still, the state of the art is still some way away from an adaptive system that's changing over time. And then sort of by the time you add the uncertainty around interactions as well as sort of reasoning, then you are in a more complex space. So it's still very much a research area, although AI is used quite a lot in the wild now. It's not sort of some fanciful future science fiction, which it has been at various bits in my career. It is now a reality, but sort of the guarantees that you can give around it are still lag behind, and it's still research that needs to be done. So luckily for us folk who are still doing research, it's good that there's plenty to keep us going.
Certainly, I think we feel that way in the cyber.
Yeah.
We do.
Exactly.
I wonder, the other sort of topic that usually comes up around issues in AI is around data bias, and whether we're looking at supervised or unsupervised types of models. Particularly in cyber, there's so many different styles of attacks. They vary vastly between industries. How much of an issue do you feel data bias is in the current deployment of AI systems?
I think it is a significant issue in several AI systems that have been deployed. There's there's several examples of various forms of bias in terms of training data, be that sort of facial recognition or sort of types of people whose data is included in the system. So it's clear to me that if you put rubbish data in and you learn from rubbish data, lo and behold, you'll end up with rubbish or biased outcomes. And I think sort of that's now much more recognized than it ever was previously. It was always kind of known, but sort of people spent so much time actually trying to get the systems to do something useful that they didn't have to worry too much about it being biased, because actually it couldn't do anything useful. Now they can do something useful. Absolutely, we need to look at these things. And I think it's really important that you get that sort of full diverse set of data training coming into these systems, and you take as broad a heterogeneous set as you possibly can. Otherwise, you're going to be vulnerable to things that you haven't seen.
I think that's something that's really interesting in the COVID-19 world. One of the other things that I think is often cited around training sets is how do we detect sort of extreme events that we're sort of living through today? If they're unlikely to be in data training sets, how are they going to be predicted in the real model?
Yeah, and it's another research challenge. I mean, there are various, as a mathematician, you all know, there are many sort of standard techniques in statistics about sampling and making sure that you're sampling from a broad enough set of distributions. And what you want to be able to do is, in the end, you want the AI system to be able to sort of, or have a wrap around it to know that it has weaknesses in particular areas, because maybe it's not seen very much training data. And that goes back to the sort of the uncertainty piece that I spoke about at the beginning. So it's great if you're in a space where you've had lots of data, you feel confident that what you've seen is a good thing. But when you're at your boundaries, or this is unusual, or I've just not got much data around this, then actually you want the system to still be able to recognize that and to sort of fess up about it.
Certainly, I think one of the most powerful bits of maths I love is just a simple Monte Carlo simulation.
Yeah.
The power of a Monte Carlo simulation can't be underestimated.
We like a good Monte Carlo.
Yeah, it's a simple but hugely effective, especially predicting extreme risk. So I wonder now if we maybe move to some of the future of AI. I think as we talked a little bit, there's so many products out there becoming so much more widespread, and particularly more sort of AI class tools with GUIs wrapped around them that allow non-experts to operate them. In some cases, tools such as natural language processing are presented as black boxes with sort of no understanding of the accuracy, precision, false positive, true positive rate. How useful are these tools? Do they provide a false sense of security, or is there some use cases where they're useful?
So you're right. I think there's a burgeoning industry in sort of AI tools coming around.
Yeah.
I see a number of these that are marketing claims about AI, more to do with sort of driving up stock prices than any technology associated with them. So it is a popular phrase to be doing to bandy about, and people do bandy it about for those reasons. Having said that, there are also many good examples of systems that are using AI and ML for good. but I think it's important when we do develop these things that there are some principles that are followed, and there are sort of starting to emerge a number of sort of frameworks for ethical deployment of AI and sort of algorithmic accountability of systems that are being deployed that I think are good sort of checklists and things that should help people deploy AI and figure out which kinds of tools that they should use. And in general, I think if you're stuck with a black box that you don't know what it does, you don't know how it does it, you don't know what it's been trained on, then you should be very cautious about deploying it broadly, because you have no real, you have very limited confidence in terms of actually what it's going to do in different circumstances. I think sort of open source software, explicit data, and sort of an analysis of how it's been constructed, how it operates is really important. And I think companies would have to think really carefully before taking something that's a black box that you can't probe in a meaningful way.
Certainly, I think with the ease that you can operate them, it's tempting. But
yeah, exactly, and sort of it's great that these days you don't need a PhD in AI or statistics to use these systems. You know, that has to be the way. AI systems have to be usable by competent users who aren't expert in these things. But if you don't know what you're doing, and you don't know the limitations, and you don't of both the system and the way that's been trained, then you can very easily lull yourself into thinking that you've got a swanky AI system solving your problem when in fact you have not.
Certainly, I think I wonder if moving towards the future we'll see any vulnerabilities being published in AIs. I think there's been some use cases of them being certainly manipulated to gains, but I wonder more security vulnerabilities rather than sort of manipulation and those sort of nefarious purposes.
Yeah, absolutely. So AI is as we've discussed, a sort of general technology, and people will use it for good and people will use it for ill, as they do with all technologies. You know, think about the web. In general, the web is a fantastic boon for society, but there's also an awful lot of bad stuff goes on the web, and AI will be the same. You sort of hinted at some of the sort of adversarial machine learning type work where you try and sort of fool a system by giving it data into thinking that this is normal or that this is a particular way to handle something, and then open up that vulnerability as it kind of focuses over here. So I think that's something to be guarded of. I think AI systems will both be used to defend those systems and also to look for vulnerabilities. As I said, in that sort of pen testing mode as well. You'll have AIs doing various battles with other AIs, I think.
Following on from that, I think that this is probably quite a big question, so apologies if this is quite a broad one, but I wonder if you have any views on how the world of AI and machine learning can be demystified for those outside of the industry. For example, as a mathematician, since the pandemic began, I've seen more and more people using the term exponential to mean growing quickly rather than like the exponential function. But
yeah.
Is it a problem? How do we combat it? What are your thoughts on that?
So I think one of the most frustrating things for me as an AI researcher is sort of the press that it gets. The sort of AI's going to take over the world. We're going to have a singularity. None of us are going to have jobs because of AI, and I just think that's rubbish. I don't see that happening anytime soon, and sort of I think my voice or my perception is held by the majority of people who actually work in AI. There are some people who are towards the stronger end of view, so it's not just non-experts who give these views, but sort of the slightly duller. This is an important and powerful technology. It's got some great strengths and weaknesses, and this is not going to happen. Is generally a less interesting and less newsworthy piece, then we're all doomed.
Yeah.
And I think it is important that sort of we get out and rebalance some of that dialogue. So a lot of the work that we're doing, for example, through the UK government's AI Council, is around sort of narratives for AI, positive narratives for AI. Not saying everything is rosy in the garden, but sort of, you know, this is the kind of things that AI is good for. You know, it will help people live better, longer, healthier, more fulfilling lives.
Yeah.
There are a number of challenges with that and things that need to still be fixed, but sort of in general, it should be a force for good. And then sort of trying to explain what's involved in it. I think the pandemic is a really interesting example of people starting to look at data and graphs way more than they have done previously, I think. But sort of again, you'll know about the things that can be inferred, or people think they can infer from graphs, is not always what it should be. And so I think there is a general campaign around required around AI and data literacy. So I think everyone should be data literate, and I think everyone should be taught data literacy from primary school upwards. Doesn't mean to say they should all program AI systems, but they should understand the values of data. They should be able to probe data. They should be able to figure out what you can and can't infer from data, because I think that's a skill that everyone needs in today's society. And I think as that improves and as that starts to come online, then sort of it makes it an easier job to start talking about what some of the processing of these sorts of data can lead to, some of the things it can do, some of the things it can't do. But I think at least some positive narrative is a start.
Yeah, that's interesting, because I don't know, probably this is my bias coming in here. When I think of AI, I don't think of something negative. So it's interesting to hear that majority perspective. But I think that the issue around data literacy and talking about graphs and whatnot, perhaps the bar we need to lift slowly over a period of time. Is that what you're suggesting, rather than?
Yes, I don't think there's I think it's a generational. I think it's a generational thing. You start from early years and sort of really embed that sort of data literacy, and you know that's a generational shift. I think we also need to think about sort of training and retraining skills. You know, there's a massive shortage of data scientists and cybersecurity experts in the tech space. I think sort of bringing more people in and more diverse people in is a really important part in both of those things. You know, neither of those industries are particularly diverse on many dimensions.
Yeah, certainly. I think when it comes to sort of people purchasing AI, and specifically marketing, I think you touched on this briefly. It can be what I like to call sort of buzzword bingo. I wonder if you have any sort of tips. That's probably too crude a word for it. Any ideas of how that process can be simplified for people from the outside looking at products?
So I think I think there's a general piece around literacy for AI and AI systems in general, and I think that's important. I think some form of guidance around sort of the standards and the ethics and the checks that have gone around AI systems and software systems in general, I think is needed to help people navigate their way through those. Sorry, it's just someone's just delivered something. I don't think I need to go and sign for it. So I think some frameworks will emerge such that they will have some form of kite mark associated with them. This is kind of legit AI, or this is AI that's been through this body of ethics, and that might be a standards body, or that might be a particular from other organisations, but I think that will inevitably follow.
I'd hope that that's the case too. I think that would be very valuable and something I'd be very keen to share. But I wonder then, that's me out of questions, but I wonder before we wrap up, is there anything you haven't covered that you would like to discuss?
No, I think a point I would make, which you made right at the beginning, and I'm not sure I gave you a really full answer, is that sort of it's been a great journey. So I've been an AI researcher for 30 odd years now, which makes me sound incredibly old when I say something like that. Actually, I was really pleased with the medal, and I got it jointly with a colleague of mine, Mike Wardridge, who we've collaborated with for a long time. And sort of, I feel sort of for our field of multi-agent systems, it's really good to sort of come into the fold of respectability of it being recognised that this is an important discipline that can make contributions. And as you say, when we started, I reckon at one point I used to know everyone in the world who worked in my research area. The 10 of us or the 20 of us who that was, and thankfully that is far from true now, and it's great to sort of see the field really burgeon.
Absolutely, I think it's just bright.
Good.
Thank you so much and have a lovely weekend.
And you, Alex. Cheers then.
Bye-bye.
Bye.